Now we're going to look at a generalization of Rolle's theorem called the mean value theorem. The statement is very similar. We're looking at a continuous function f of x that is differentiable on this range from a to b, but we're no longer assuming that f of a is equal to f of b. And now the conclusion is that there's some x value c between a and b such that f prime of c is equal to f of b minus f of a over b minus a. And this one is best explained with a picture. So let's say we have some function y equals f of x defined on some range here from a to b. Now this thing on the right-hand side, well, look at that. That's a difference in outputs divided by a difference in inputs. So it's a slope of some sort. And in fact, it's the slope of what we call a secant line. That's the line that connects the sort of start point and the end point of this bit of function graph right here. Okay, so the slope of this is that f of b minus f of a over b minus a. Now we know that f prime tells you about the slopes of tangent lines. So this is the slope of a tangent line at some x value c. And so what the mean value theorem is saying is that there must be some x value c where the slope of that tangent line is equal to the slope of this secant line that I drew right here. And to say that two lines have the same slope is to say that they are parallel lines. So you notice here's a line, skims the graph right about there. So the slope of this line right here is f prime of c. And so there you go. In this case, we were able to find, sort of just freehand drawing, a tangent line with the same slope as this secant line right here. And so the mean value theorem says that that always happens. Now, how do we prove this? I'm going to show this to you because it's really kind of a nice proof. It just uses Rolle's theorem. So what I want to do is say, I have this graph y equals f of x that I had before, and I'm going to write an equation for the secant line. So let's let g of x be that secant line. Well, then that should be something like the slope times x minus the x-coordinate plus the y-coordinate. So that looks like this. It's going to look a little bit messy because the slope is a little bit messy. It's going to be, well, actually, you know what? Maybe let me just leave it like that for right now. We're going to come back and say m is f of b minus f of a over b minus a. But let's leave it as m as long as we can. And now we're going to define one more function, h of x, which is going to be f of x minus g of x. Now, we note that f was continuous and differentiable, and well, so is g. I mean, g is just the equation of a straight line, so that's continuous everywhere, it's differentiable everywhere. And if f and g are both continuous and differentiable, well then so is f minus g. So h itself is a continuous and differentiable function. Now what's h of a? Well, it's f of a minus g of a. And remember, g of x was given by this equation right here. And if you look at it, you see that, well, look, when I plug a in for x, you're going to get m times 0 plus f of a. So in fact, you end up with f of a minus f of a, so 0. What about h of b? So that's f of b minus g of b. So what's g of b? Well, g of b looks like this. It's m times b minus a plus f of a. And now here's where we're going to want to use what m actually is. Remember, m is f of b minus f of a all over b minus a. So that means that m times b minus a is actually f of b minus f of a. So I have f of b minus f of a, that was what this first part became, plus f of a. So I have a minus f of a plus f of a, which cancel, and then an f of b minus f of b, which cancel, so that's 0. So h of a and h of b are both, in fact, 0. Well, if I have a continuous differentiable function where h of a and h of b are the same, that means I can use Rolle's theorem. So now Rolle's theorem says that h prime of c is 0 for some c between a and b. Well, h prime of c, since h is this function f minus g, h prime of c is f prime of c minus g prime of c. And so, in fact, f prime of c must be equal to g prime of c at some value c. But now what's g prime of c? G, let me scroll back up just a minute here. G of x was this secant line. That's just a linear function. F of a is a constant, so when I take the derivative of g, that part's going to drop away. And then I have m times x minus a. So in fact, g prime of x is just m. So finally, that means that if f prime of c is g prime of c, then in fact f prime of c is equal to m, and m, remember, was f of b minus f of a over b minus a. So there you go. That's the thing that we wanted to show. So by doing kind of a clever transformation, we were able to use Rolle's theorem to prove the mean value theorem. Okay, next time we'll see some examples of how to use the mean value theorem.